Welcome back everyone to part 2, or our second phase of the Keras Regression Code Along project. We've already taken a look at the features, done a little bit of feature engineering, and even dropped some features. Now it's time to scale along with train test split, and then create a model and train the model. Let's get started. Okay, after we finish all our feature engineering, the next step is to separate our features from our label. And we can do this by assigning x to df drop price along axes equal to 1, and then the other thing we're going to do is say y is equal to df price. And to make sure there's no issues between the pandas data types and the numpy numerics, we can also just request the values. So if you say dot values, this returns back the numpy array underneath the actual data frames or pandas series. So we run those. And now that we have separated our features from our label, it's time to do a train test split. We will say from sklearn dot model selection import a train test split. Run that, and the way I like to do this to save myself a little bit of typing time is just grab the example from the doc string and copy and paste it in here. So we'll just go ahead and grab that, copy it, paste it in. I would encourage you to do the same. And what I'm going to do is I'm going to set my test size to just be 30%, and I'll also set my random state to be 101. Again, arbitrary number choice. It's just that we're consistent across the notebook. So go ahead and choose the same random state I do. That way you can compare your results directly. Okay, so we'll go ahead and run this. We've done our split. Now it's time to actually perform the scaling. Remember, we want to do the scaling post-split. That way we only fit to the training set to prevent data leakage from the test set. We'll do this just as we've done before by saying sklearn.preprocessing import min-max scaler. You can technically use any scaling you like, but min-max scaler is simpler to understand. So we'll use it in this case, min-max scaler. And then we will redefine our training set as the scaled versions. And I can save a little bit of time by both fitting and transforming on my training set in one step. So previously we saw us fit and transform in 2 steps, but scaling actually has this convenience feature of transforming and then fitting at 1 step. So we'll go ahead and do that. And then for the test set, recall here we're just going to transform. We don't fit to our test set because we don't want to assume prior information about our test set. So there's our training set, and there's our test set. Now they've been scaled. Coming up next, what we're going to do is actually create the model. So we'll do the following. We'll say from tensorflow.keras.models import sequential. And then we'll also say from tensorflow.keras.layers import, and we're going to import a dense layer. So we run that. And let's create our model. So we create a sequential model, and typically what we do is we try to base the number of neurons or units in our layers from the size of the actual feature data. So let's take a quick look at the shape of our data. So it looks like we have 19 incoming features, and that's probably a good range to then have 19 neurons in our layer. So we'll say model add dense 19, and we'll also say that the activation layer will be a rectified linear unit. Now let's make sure we actually spell this correctly, sequential. Now something that we're going to explore later on is to see how we can use early stopping in order to try to choose the correct number of epochs to train for, but also to try to choose the correct number of layers to train for. For right now though, I'm just going to copy and paste this line a couple of times to add in and make this a deep learning network. Now, this may be overkill, and we may end up overfitting slightly to the training data, but we'll be able to explore whether or not that's happening by passing in validation data along with our training. So what I will do here is add one more final layer, and this last final layer is just going to have 1 neuron as its output, since that's going to be directly outputting our predicted price. And then we are going to compile this model. And previously, in the theory sections of these lectures, we went ahead and talked about Atom Optimizer being a good optimizer, so we'll choose it by passing in the string code atom. And since this is a regression problem, we're choosing a continuous label, such as price. We'll go ahead and choose our loss metric as mean squared error. Okay, so we go ahead and run that, and now it's time to train the model. We will say model.fit, and then what I'm going to pass here is my training data, just as we've done before. So xtrain, and then ytrain. And the next thing I'm going to do is also pass in validation data. If we do Shift Tab here, you'll notice that you can pass in the data to train on, x and y, and you can also pass in validation data. And what that means is after each epoch of training on the training data, we'll quickly run the test data and check our loss on the test data. So that way we can keep a tracking of how well we're performing, not just on our training data, but also on our test data. Keep in mind, this test data will not actually affect the weights or biases of our network. So Keras isn't going to update your model based off the test data or validation data. Instead, it will only use the training data as it's updating the weights and biases and continue to essentially check how well it's doing on not just the training data, but also the validation data. And the way we pass this in is by saying validation data is equal to, and then we pass in our values here. So we're going to say x test and then y test. And we want to make sure that we actually consider the values here. So something you have to make sure of is that you call dot values here, because TensorFlow may complain if you don't pass in a numeric array because it can't work with pandas series or data frames that well. So make sure you've done the values. And as again, what we're doing here is we're training on xtrain, ytrain, but as we go along, we want to be checking against our test set. And that will give us some nice plots to basically realize whether or not we're overfitting. So add in the validation data. And finally, because this is a larger data set, we're going to feed in our data in batches. And we're going to call batch size of 128. It's very typical to do batch sizes in powers of 2, so 64, 128, 256. The smaller the batch size, the longer training is going to take, but the less likely you're going to overfit to your data because you're not passing in your entire training set at once. Instead, you're focusing on these smaller batches. And then finally, let's go ahead and choose kind of an arbitrary large number of epochs, so 400. We don't have any early stopping mechanisms yet. We'll learn about those later on in the course. But for right now, we'll do 400. That way I can see those nice curves and also compare my training performance to my test performance. So go ahead and run this. And hopefully, if you've done everything correctly, you should be getting to see the output. If you get some sort of error code here, make sure you reference our notebook, and you can go ahead and run our notebook directly in order to prevent any simple typo errors. Okay, so this is training on our data set right now. Coming up in the next lecture, we'll go ahead and finish this training. So we'll kind of fast forward through this, and then we'll start evaluating on our test data set, as well as predict on brand new data. So again, all we've done in this lecture is we've scaled our data after doing the train test split, created our model, and then kind of the new thing that we saw here is adding in validation data during the fitting, as well as choosing a batch size. Okay, thanks, and I'll see you at the next lecture.